Hi everyone! In this lesson, we'll start by discussing the driver sheet of our model. As you can see, I have listed several parameters we will need later on. In general, it is very good practice to add a driver sheet to a financial model. This is a nice way to group and organize all external inputs that have been factored into the model. Let's go through each of these parameters and discuss their application, shall we? First, we have the selected case. Given that we are trying to create a flexible model, the idea here is to add a field which would allow us to change scenarios. It is a good idea to include at least a few scenarios and analyze different states of the world by changing the selected case. We will have 3 scenarios designated with the numbers 1, 2, and 3. Scenario 1 is our best case scenario. Scenario 2 is the base case. And Scenario 3 designates a worst case situation. It will be very insightful to see how Tesla's financials and overall cash flow look in each of these scenarios. Later on, when the model is ready, we will be able to switch between scenarios from here. Given that we want this cell to have only 3 possible values, 1, 2, and 3, we don't want it to be anything else. I'll use data validation to set a list with these values. Okay, obviously the company we will work with here is Tesla. But to build a flexible model, I'll add this as an input here. And we'll show you why this can be useful a bit later on. Tesla resides in the US, and the currency we will be using for our model is USD. The 10-year Treasury yield, as of the 27th of September 2018, is 3.07%. I've added a screenshot taken from CNBC's website. To find it yourself, all you have to do is type US 10-year Treasury in Google. The long-term market risk premium for hold U.S. stocks has been proven to be in the range between 4.5% and 5.5%. So let's use an average value of 5% in this case. Also, if we open Tesla's profile on Yahoo Finance, you'll be able to see that the company's beta is 0.78 and that it traded at $307.8. Okay, perfect. Another detail we'll need to add here is Tesla's bond yield. That is the rate of return offered to people buying the company's debt on the market. This is a really good approximation of a market rate of cost of debt. In Tesla's case, we found that its bond yield, as of the middle of September 2018, was 7.5%. The last 2 parameters we'll need later on are corporate tax rate and expected inflation. We'll need to estimate both. Let's use 30% as an approximation for Tesla's corporate tax rate in the US, and also 2% as the expected long-term value of inflation. Bear in mind that both of these values are typically applied in similar valuation models. All right, great. Our driver sheet is ready. Next on our agenda, historical inputs, and the way we will organize them in our model. Thanks for watching.